So we'll add the final 4 wires to our CPU, which are used to control the external devices like the monitor and the keyboard. We now have a nearly complete picture of what the Scott CPU looks like. Data moves around inside the CPU using the bus and is stored in each register according to how that data is going to be used. Each instruction that we have seen can be processed by the Scott CPU in about 6 clock ticks. Modern CPUs can process multiple instructions per clock tick, meaning that the computer you're using to watch this video is likely processing tens or even hundreds of billions of instructions per second. That phenomenal speed is accomplished by using more than one of each component and making sure that all the components are active as much as possible. This makes modern CPUs much more complicated than the Scott CPU, but they are still fundamentally doing the same things as the Scott CPU. So now let's zoom back out and we can see all the wires that run back out to the pins on the chip. On the right are the set RAM and enable RAM wires. On the top are the RAM address wires. On the bottom are the data wires that run to both RAM and the external devices. And on the left are the input-output control wires. So let's zoom back out to see the rest of the chip, and we'll put the cover back on the CPU and put it back in the motherboard. Using the ports on the left, we can now plug in the cables that connect our monitor and our keyboard. Each of these ports has an address, and that port address is what the CPU uses with an in or an out instruction. That port address, by the way, is sent using the data bus, since the address bus in this computer is only used for RAM. So we'll zoom out to see how the motherboard fits inside the computer case. In the computer case is the last component we'll look at, which is the hard drive. As soon as the power to the computer is turned off, all the data in RAM is lost, so you have to have a way to store it more permanently. For that, we use a hard drive. Inside the hard drive is a spinning disk covered in tiny magnets with a small metal arm floating above it. The arm moves around to the different parts of the disk where different data can be stored and retrieved. The disk and the arm generally move very, very quickly, but nowhere near as fast as the CPU can process data. For this reason, all the data from the hard drive must first be moved to RAM before it can be processed. So we'll put the hard drive back inside the computer and zoom out.